Hello all, I am Spandana from Group 352. Our project Avatar Lab focused on creating a talking head AI, essentially a virtual avatar capable of mimicking human-like speech and facial expressions. Architecture evolution. Regarding the questions, architecture evolution, as we dive deeper, the original architecture underwent several refinements, especially after encountering all the integration and performance issues. And the team challenges and I faced were the common issues like complex hurdles like the model compatibility issues, and there were many internal server issues, and syncing of TTS with the facial movements, and optimizing system performance under the resource constraints. It was very hard to do. And Why did we choose only these models? We choose specific the AI models like Zonus and Latent Sync for the superior accuracy in speech to face alignment and natural expression generation. And moving on to the next, and here we have the here why did we what did we learn during this project? Here in this each challenge which had made improvement to refine our pipeline and increase the efficiency and make the model work even more optimized or enhanced way. And moving on to the next, the system architecture and the core workflow. Here we have the user interacting in the front web page, where we build up with a React and CSS. Here in the login page is a register page, also called as sign up page, and the is login, and the details like the first name, last name, email, password are saved into the MongoDB, the database layer. And here we have the template section where the video and audio is given and the text is given as an input, and the user chooses the template. There are 6 templates are given in the front end, and which are chosen, and the secured API call is sent to the Zonus with a sample audio which is given in the front end, which and including text is given to the secured API call with to the Zonus, and the Zonus creates a .wav file, and the .wav file is sent again to the latent sync with a video with a mention template, and the latent sync generates a MP4 file of little MB like 1 point, not more than 5 MB is generated and is sent to the result page. In the result page, the result page again is back to the front end, and the user can see the video. And here coming back to the workflow, here we have the get started and sign up or login page, whatever you name it. And and after login, the template section is given. Here the template is selected, the video is generated using the Zonus and the latency. uh, and the video is generated is again sent back to the front end. Moving on to the next, we have challenges. Throughout this process, sorry, throughout this project, we faced some key technical issues. Integrating text to speech with accurate facial animation was tough, especially maintaining the real time performance. We also ran into dependency conflicts between the different AI components, and there were port conflicts, and there was a complex model issues, and generating natural facial expressions proved harder than expected. And to overcome this all the above challenges which we faced, we developed an advanced lip syncing alignment system and leveraged GPU acceleration to improve speed. We moved our backend to the cloud for scalability and streamlined our data processing pipeline. Here in the backend, we have for the backend to the cloud. Here we use the AWS and Firebase. As for now, we are storing the output locally, as it cost in the cloud. So these solutions paid off, and we successfully integrated a full stack, achieved a smooth deep learning driven facial expressions, and set up a solid testing strategies. And we why Zonus and latent sync? We specifically choose Zonus for its emotional voice synthesis, where we can It's also called as customizable prosody. We can usually fine tune, or we can lower or high the pitch. And why latent sync? Latent sync is used for its precision in syncing facial movements with speech. Together, they helped us to create avatars that don't just speak, they feel like human. And moving on to the next, we have the code explained, or the front end to be explained. Here we have the Flask the lip sync Python program, and the TTS Zonus Python program. Here we have the as we choose the API calls. Here the transcript is entered. Here from the JSX file, the transcript is taken. See, set transcript. As a transcript is taken here. And it is sent back to the and again it is linked the front end is again linked with the template.jsx. And here where the templates are taken, the templates are taken and chosen, and which are sent to the again to the API call to the backend. And here the video output is here the video output is given. And here the video output is supported. And here when we again generate it, then sometimes it doesn't support the video tag. Sometimes it cannot be generated, and the error is persisted at the time. And again, coming back to the backend, we have lipsync.py. Here in this the latent sync, the the request the port request has been sent to the port request has been sent to the uh, as I said, there are port conflicts here. The port 6900 is sent to the call from the front end. The template, the video which is selected is sent to the again in the TTS. We have in this also the port is the API dot generate speech is generated, and which is sent back again to the lipsync.py. And here the and here, as we can see, here the model dot generator of conditioning is one of the most important line of this whole code. And the port is sent to the and mentioned there are different ports here, uh, where the API calls are sent. The first TTS model audio is sent back to the lip sync latent sync. In this latent sync, we have uh, the generated wave file as well as the template, and the output generated video is sent back to here. And after here we have to first install all the note required JSON formats, required React formats and all. And after that we can there was another issue faced, that was 3. This is one of the file which was not found. One of the challenges which I faced, npm i3. This is one of the package have to be installed separately. And here we have then npm start, the React has been started here. And this is the page. uh, I'm sorry. Here is our front end page, the talking at AI. Here is the light switch. Uh, for the night mode and the dark mode, people who like for it. This is the front end page, how it works and the template preview and all. And right now, as I was login earlier, so I don't have to log in again. So there were six templates were given as I previously mentioned. So I'm gonna choose this person and click confirm selection and proceed. And here you type this, type something, type the prompt, hello, this is a sample video. So here is the final output, the transcript video, which is generated. This is a sample testing of the project demo, and the video is generated. Here is the reason for displaying the recording is only that only one of our team member has the high-end GPU, so the output is shown only as the recording, cannot be shown cannot be shown directly from my laptop, and and the output is here. And here in the backend, we have used the Flask.
This is a sample testing of the project demo. This is a sample testing of the project demo.
Um, and in the backend, we have used the in the backend we have used the Flask, as well as the Docker. Flask for the backend, because it has stored the it um, stores all the contents which are given, and we are using the Docker to isolate the both of the AI models in order to avoid all the conflicts and the hurdles which are going to be faced. Uh, thank you, thank you for listening. Thank you so much.